Okay, in this video I'm going to talk a little bit about how to identify influential data points, possible outliers, following your simple linear regression analysis. And we're going to be using the Stata program to do this. So in my previous videos I ran a simple regression model where basically what we had was a dependent variable achievement or criterion variable achievement and independent variable or predictor variable performance goals. And so I ran the analysis, and we had our data analysis completed. I also generated residuals, or unstandardized residuals and standardized residuals, and essentially save those to my data set. So here's my data with my performance goal and achievement variables. Over here you can see that I had created a new variable residual and standardized residual. And so in this case right here, what I want to do is to briefly talk about ways of, again, identifying possible outliers in your data set. One way to identify potential outlying cases is to look at the standardized residuals. So again, basically the way that I requested that to appear in the data set, all I did was I just typed in predict, and I had to create a name. So basically I just called it, I think I just called it STANDR. I'll just create a new one. It'll have the same values on it, but just to kind of reiterate how this was done. So I'll just call this 2 right here. So that's just the variable name that's going to be created to the data set. The command itself is rstandard to create those standardized residuals. And so now you can see I've just created this new variable, which are essentially z-scored versions of the unstandardized residuals. So if I go to my data set and go under data editor, what I'm essentially looking for are standardized residuals. So again, these values are exactly the same intentionally in this case. So what I'm looking for are standardized residuals that fall within, basically to identify an outlier, I'm looking for residuals that have a value that's greater than 2 or less than -2. There are other rules of thumb. I've seen suggestions of an absolute value greater than 3 as reflecting more likely an outlier. But I'm just going to stick with 2 standard deviation units right now as the criteria. So you can see that really as we go down, looking at all these, you can see that there are none that really exceed an absolute value of 2 when it comes to being as indicating a possible outlier. Here now, in this case, we do have a case where basically this person is a little bit over 3 standard deviation units above the mean of the residuals, which would be 0. So even using the rule of thumb of 2 or 3 in absolute value, in both of those cases, this would clearly be an indicator of a possible outlier. So basically, case number 46 is a big question mark. So kind of scrolling down, let's see if we can find any other ones. Okay, and we could have done this generally by requesting a frequency distribution, at least to get an idea about which values, how many were falling out in those, or how many values might be indicative of an outlier. It looks like we basically have one case that is really questionable, and we've already identified that case as case number 46. So so right there we have one way in which we can assess for outliers. Another variant on this is the studentized residuals, and these are a little bit more sensitive when it comes to identifying possible outliers. So we would just create a new variable and we would say predict. I'm just going to call it student and then the command itself is rstudent. Then press enter, and so now we have the studentized residuals have been added to the data set. And so we basically use the same rules of thumb that we were using with the standardized residuals. So I'm going to go to data editor again, and now I have my new variable student, and I can just kind of scroll down, and you can see that really all of them look good except for that number 46. So you can see that the value is actually a little larger here, and clearly again suggesting that we have a possible outlying case with case number 46. As we scroll down, we have another case. If we were using the two sort of a threshold of absolute value of 2, or then this might also be a possible outlier. It's not very great, but it's, I guess we could still say it's possible. But you can see, and actually that was the case with our z-score as well. So if we were using the threshold of 3 in absolute value, that would not be considered an outlier. But again, I'm kind of adopting a more liberal standard in terms of identifying possible outliers. So at any rate, so we have case 46 is most likely an outlier, and case number 123 is, just depending on the threshold that you adopt, may or may not be considered an outlier. So, so you can basically, like I said, you can use the standardized residuals or the studentized residuals or both. So another type of way in which we can assess for possible outlying cases is to essentially look at the influence of the case on the regression results. So there are a couple of indices that we can look at. The first one is called Cook's D. So with Cook's D, I'll just write this up here really quickly. So we have Cook's D. And essentially, this is sort of a way of assessing the influence of a case on the overall regression results. So we can, so to do this, we have to basically create a new variable in our data set. So we're going to use the predict command again, and we're going to give each case will have a Cook's D value. And so what we'll do is we have to name the new variable. So we'll just call it, I'm just going to call it Cook's, and then followed by Cook's D, and this is the actual command for computing Cook's D values for all the cases. So the variable in the data set will be called Cook's. Then I'll press enter, and so now we have Cook's D that's been computed for each of those data sets, for each case. So if I go to data editor under browse, now you can see that we have Cook's D that's been created. And basically what we're looking for, there are various rules of thumb for this. One of them is that if a case has a Cook's D value that's greater than 1, then that may be a problematic case. So the lowest value for Cook's D is 0, and so what we're looking for are values that are greater than 1. So scanning the cases, and this is in scientific notation, so that's actually a decimal value with it would actually be 0.000006. So that's not meeting our threshold either. So that's a very small number actually. We have another very small number here and a very small number here. So at any rate, as we kind of scroll down, one of our problematic cases that we identified was number 46, and you can see actually in this case the Cook's D value is less than 1, suggesting that it's not having an undue influence on the results. If we continue down, you can see that basically all of these values look pretty good. Let's look at 123, which is another question mark, and that appears not to be having an undue influence as well. So overall, none of the cases exhibited Cook-Stee values that would be considered overly influential, or representing an overly influential observation on the results. Now, Cook-Stee sort of summarizes overall influence, but then there's also the influence on individual regression parameters. So if we want to look at the influence on individual regression parameters, what we can do is to request DF beta values. So in other words, DF beta values. So in other words, what we're looking for are the effects of an individual case on an individual regression coefficient. So so with DF beta values, essentially what we're going to do is we're going to create variables that also go into our data set that capture the amount of influence an individual case has on a particular regression coefficient. And so the DF beta command is how we're going to do this. So basically what we can do is we can go down to, we'll use the predict command again. So predict, and I'm just going to call, let's see, we have our variable is performance goal. So I'm just going to call it DF perform. Just as a general name, because what we're going to be looking at is the influence of an individual observation on this regression coefficient right here. So then I'm going to type in DF beta and then perform and click on OK. And I gave it the wrong name, so I have to do this again. So DF beta, and the variable name was PRFOR, so, excuse me, goal. All right, so there we go. So now we have our new variable listed in the regression in our data set. So we just basically go back to data editor. Oops, I don't want to change the mode. I want to keep it on browse mode. So now in this case, here is our new variable. Okay, so when it comes to identifying what are considered to be more highly influential cases, the way that you would interpret the DF betas is basically the first thing you need to do is to compute sort of a threshold for what constitutes a highly influential case. So the rule of thumb is basically that DF B values or DF beta values that are greater than 2 divided by the square root of n for your sample size would be considered more highly influential cases. So in our current sample, we had 129 cases that were included in the regression analysis. So we're just basically dividing 2 divided by the square root of 129. And by the way, this is the we're looking for DFB values that are an absolute value greater than this. So it's the absolute value that matters. So because you can obviously see we have positive and negative values of this. So in our case, our threshold for judging more highly influential cases is 0.176. So we're looking for DFB values that are an absolute value that exceed 0.176. Okay, so let's just kind of go down and look and see what we have. So you can see that and quite frankly, before I do this, this is kind of a pain in the neck to go case by case. So I'm going to go to data and then down to sort data, and then sort ascending on this particular variable. So I'm just going to click on submit, and now I've got everything sorted together. So the threshold was 0.176 in absolute value. So you can see right here that that this case right here, this case right here, and this case right here are possible influential observations. This one being the most highly influential, followed by these two right here. So this is actually a fairly borderline case right here, whereas these two are much more substantial. If we look on the positive side, you can see that this was actually the previous number 46. And so you can see that this case, this case, this case, this case, these four observations seem to have more influence on the regression parameter. So at any rate, that's how you can basically identify possible outlying cases and also influential observations. So hopefully this will be helpful to you, and that will conclude this discussion.